So we've talked about very traditional workhorses of machine learning that have not only been around in some cases for decades, but that have been a very active source of development in industry for the last decade in healthcare. So unsupervised learning and linear methods, these are both very useful. Now I'm going to talk about the third major subject we'll treat in the series, which is deep learning. Deep learning has had an explosion of use since 2012 when it became much more computationally feasible to do very, very deep neural network models. So I want to talk a bit just about what a neural network is for those audience members who haven't encountered this. Neural networks themselves are an old technology. They date back to the 70s, but they are newly interesting and powerful since 2012 in industry, and that includes in healthcare. So a neural network, if you look at it, I have a very simple diagram here, can have as many inputs as you want and as many outputs as you want. And what you tend to do is then have one or preferably many hidden layers, which is the layer between the input and the output. And then you connect these layers with different weights. And the point of the neural network is it learns what weights will give you the output you want based on the input you have. So first notice this is a supervised learning problem because there is a correct answer. You are grading the outputs against the desired outputs. The other thing you should notice, based on the fact that you can have many hidden layers, is the fact that this can become quite computationally taxing, right? So in industry and healthcare applications, for example, it's very common to have 40 or even 1,000 hidden layers. So that means between your input, that could be a medical image, it could be a patient's diagnostic history, it could be a series of blood sugars, from which you could have maybe one output, say like categorizing the type of tumor or predicting the next blood glucose level or classifying the patient depending on their medical records over their lifetime. You can have 1,000 different layers that are all doing different things. And we have found that this very well simulates how humans think. And in fact, in the last year or two, deep learning algorithms have been able to do just as well as some of the country's best specialists, such as in radiology or dermatology, purely with training. And these are really continuing to grow as fast as input data becomes available. So this is due to the fact that neural networks, if sufficiently wide or sufficiently deep, can approximate any function. Before 2012, people were really aiming for very wide neural networks, but what was discovered then is that very deep networks can behave just as well as very wide networks, and they're much more computationally tractable. So that's why we have these deep learning explosion now. These neural networks we are finding in the last year or two tend to be good at the same tasks as humans. Humans, we think, are very good at healthcare. They're very good at taking many different kinds of data, synthesizing them and coming to a conclusion, or looking at radiology image sets or photographs of skin lesions and coming to a conclusion. It turns out the neural networks are good at the same things as the specialists. So just to whet your appetite, a few things that are going on recently. One is that Google Brain recently started collaborating with many major hospitals, getting anonymized patient data to try predicting when people will get sick. IBM Watson is doing something very similar. It's very exciting to see these truly enormous companies with very deep expertise and deep learning begin to finally be able to access patient records. This has probably been a monumental effort, possibly decades long, trying to get the permissions together, right? Because we've talked about the legal constraints here. What we know is these companies have been able to produce amazing results in other domains, and I think in the next year or two, we're going to see similar amazing results coming out of these large-scale health efforts. One of the reasons I am so confident of this is that so far, amateurs, people who are not very knowledgeable about neural networks, but who do have domain expertise in medicine, have had tremendous success applying these methodologies. So secondly, deep learning has already been successfully applied by non-experts to diagnosing skin cancer. This made the front page of Nature with a study from researchers who were amateur users of neural networks. With only a few hundred photographs, we're able to train a neural network that could beat the nation's best dermatologists. So this is really interesting that we have a technology that people who aren't even self-identified as machine learning experts are nonetheless able to beat dermatologists with decades of experience with only a few hundred photos. Thirdly, existing applications are primarily for image processing. This has been really exciting. And it covers a huge range of healthcare possibilities, but it's also not everything, right? So another area that's exploding, but that is not quite up to image based analysis is time series prediction. So I also believe in the next year or two we're going to see a huge explosion in time series prediction with neural networks in the healthcare field.